Hello everyone, I'm Tak Honda from Nara Institute of Science and Technology. My presentation title is Speeding up VBGMM by using logarithm exponential with the approximate exponential function. In my presentation, the first section is an explanation of VBGMM and logarithm exponential. Next is related work. And next is proposal and evaluation and result. Finally, discussion and future works. First section is VBGMM and logarithm exponential. First, I will explain about clustering. Clustering is the task of grouping input data into similar ones, as shown in Figure 1. One of the famous methods of clustering is GMM. In GMM, each group is represented by adding up the Gaussian distribution like Figure 2. Next, I will explain about VBGMM. In VBGMM, we consider some parameter in GMM as probability distribution like Figure 3, compared with another method such as the EM algorithm. VBGMM has the advantage that it is difficult to overfit like Figure 4. On the other hand, it has the disadvantage of requiring a large processing time. Next, we show the result of VBGMM profiling in Figure 5. There are three calculations that account for large percentage. The largest, 36%, is logarithm exponential calculation. Logarithm exponential is shown in Figure 6. In this figure, because n is the data size of VBGMM training, so a large amount of exponentials is required. That's why logarithm exponential account for the largest part of VBGMM calculation. Next, section 2, related works. In our laboratory, we are working on GPGPU-based acceleration of VBGMM. But in this study, we propose a software approach to speed up the VBGMM. Next, section 3 is about our proposal. In this study, we used an approximate exponential function as shown in Figure 7. Next, section 4 is I will explain about what is approximate exponential. Look at the equations. First, we transform exponentials using variable k and t as equation 1. We choose k and t so that t is small, and then exponential is represented as equation 2. Because we have chosen as variable t is small, so we define the approximate exponential as equation 3. And next, solve equation 4 to find the constant value a. Finally, approximate exponential is represented as equation 5. Next, section 5, I explain about the evaluation of VBGMM using the original and approximate exponential. The input data of clustering is 32 Gaussian distribution with 60 dimensions. And we change the data size from 10 to the 3rd to 10 to the 7th. Next, section 6 is the result. The following figure 8 and 9 shows a comparison of the computation time between original exponential and approximate exponential. Figure 10 shows the clustering result by using ARI. ARI means adjusted rand index, which is a function that measures the similarity of assignments. These experimental results show that Logsumexp is 1.923 times faster and VBGMM is 1.191 times faster, and clustering results match up to 10 to the 6th. Finally, section 7 is about discussion and future work. From the results, we found that VBGMM is speeded up, but as the data size increases, the clustering results don't match. Our future work is to improve the approximation formula to make it more accurate. And we would like to test whether this approximation is valid or not for applications other than VBGMM. My presentation is over. Thank you for listening.